If you're just starting out with Java, or you started but still figuring out the way things are in the Java world, then dive in with me and let's go through the most basic rules and small principles that you should follow in order to make your code clean, maintainable, and readable. The first remark I got when I started out as a Java developer back in 2010 was about the usage of raw numbers in my solution. I was literally slapped on my hands for doing this, as this seemed to be one of the most obvious mistakes, and that senior must have seen it countless of times done by the rookies like me back then. Let us take a deeper look into this so that you won't get slapped like I did. In this example, our hero will be fighting with a mighty dragon. Before the actual fight though, the game might reward or punish the hero. This is based on his current morale level. Now, when we first look at that part, we see a bunch of numbers which do not carry a lot of meaningful value. It is not obvious, for example, why morale level 1 drains our strength before the battle. Let us try to work a bit on these numbers. We have increased the amount of code considerably now, but have no fear. This is for the greater good. Readability is far more important, in my opinion, than a couple of extra lines of code. Now we can clearly see why the hero's strength is drained and why he gains as much as 10 points when his morale level is at level 3. Nowadays, it seems that getting things done is a superior strategy compared to the getting things done right and in line with the software engineering craft. At top of my list of sloppy practices has to be the lack of braces in your loops and conditionals. I simply cannot understand why some people want to make their life harder for themselves and, what is most important, for those who will be working on their code later on. All that for the sake of saving a half a second of development time. And this may cost actually way more than you think. Finally, we'll try to level up our hero. First, we raise the level. Then we add money if the certain level is achieved. Then we check whether the hero has done some remarkable things this past level. If so, we grant him a special spell and actually one extra level. Finally, we go through the monsters that the hero slain, and we want to grant him extra reputation so that he can get better contracts, and fame so that he can get more following in a larger number of cities. This looks to be structured quite well at first glance.
Hopefully, most of you see that behind this facade, it may work absolutely different than the game expects it to behave. Because the developer has forgot to brace his code, hopefully by mistake, the next level up process may look like this. We raise the hero's level by 1. Okay, that's fine. We add extra money to the hero if a certain level is hit. Still, so far so good. Though we could brace that code to underline that this is the only line of code that should be executed if the conditional is met. Okay, going further. If the hero did not do anything special lately, we will not grant him a spell, but he will receive an extra level anyway. Just because we forgot to brace that statement within the conditional. This small act of laziness might cause some crazy havoc once the game goes live. Okay, and finally, if the hero did not fight with anything significant, he will not get that much sought after reputation, but for some odd reason his fame will keep growing and growing. Let us try to fix this messy method. Now there is no option for overpowering your hero without actually going there and proving your worth. Because of the laziness in the most basic areas as bracing your loops and conditionals, we may have lost gamers and customers. Please make it a habit and brace even single lines of code if possible.
Don't try to think about a pink elephant. Now, how many of you started to think about something else than actually a pink elephant right now? The answer is 0. The do not try at the beginning had absolutely 0 impact on the outcome, as we as humans are not that good with negations. We are wired to do things, not to do things. The same applies to the readability of your code. If it is full of conditionals that start with negations, the developer is highly likely to be misled with the message the code is trying to convey. Guys, please do not do that.
This time we'll look at the engine of opening a treasure chest. The general logic is quite straightforward. We try to open the chest until we ran out of lockpicks. Before each attempt, the game decides whether the opening will be in hard or easy mode. If the lockpick is used method is not true, we go for the easy mode. Okay, fair enough. Then we check whether the is not opened value is not true. Then we loot all the goods and run away. Okay, this negation stuff is quite confusing, to say the least, in order to understand fairly easily this piece of logic. Let us try to remove all these negations and say what we want to happen, not the reverse. Now there is no frowning of our foreheads anymore. We say explicitly what we want to happen, and this allows us to read this code with ease.
Remember not to spend all the pocket money in one day. Remember to brush your teeth twice a day. Remember to wash your hands before each meal and do not talk to strangers. That's what probably your mom said the first time you were going on a summer camp. On the other hand, your dad most likely said something to the taste of, "Just be careful, son." And frankly, that's all you needed to hear. You should know all the details anyway at this point. You're a big boy. The idea is the same when we have to verify a complex set of Boolean expressions in our code. We can put them as they are in our conditional, or we can make it more readable and easier to understand. To put them in a way that is enough for the client to understand, with all the details inside and covered.
In this example, our hero and his army will be trying to protect their castle against a siege. Before the actual defense takes place though, the game seems to try to check some stuff, just in case. Okay, so we check that the size of our enemy's army is below 100. Okay? Then we try to, go through each of the soldiers and check whether that guy's name is general. And when the first one is true or the second one is false, we return true. Okay. Let's go to the next conditional. If the morale level of a hero is lower than 2 and the castle walls are null and hero has less than 5 allies, we return false. Okay. That is so easy to understand. Joking aside, we have to do something about all of this. We have to. About those code breaks before the defense statement. Okay, we came up with some actually human readable stuff here. We have hidden all those numbers and comparisons inside self-explanatory private members. But we still can do better. This sauce is still a bit watery. We can dense it up to have only the essence here. Right, okay. Why this has not been like this from the start? We have boiled down our sets of Boolean expressions into a single, readable, and instantly understandable conclusions. That is, whether the enemy is simply too weak to face us, or whether the hero is so down on his luck lately that the defense just does not make much sense.
With optionals introduced back in Java 1.8, we can easily eliminate the dreadful null pointer exception at runtime. If your team does not practice the usage of optionals, or you simply got assigned to work on that dreadful legacy application with absolutely no good practices implemented, don't worry, bro. All of us were there at some point. Have no fear. With the knowledge of the basics combined with some simple tricks, you can guard yourself pretty well against the NPE being thrown right there in your face.
Next up, we have an example of a hero trying to steal some of the stuff from the nearby dragon. It all looks alright from the functional perspective. If the hero does not try to steal any gold, he will just chicken out. Going further, if the dragon does not guard a minimal amount of treasure worth the hassle, we flag the dragon as broke and we just move on. As the final check, if the hero actually tries to steal, we verify that he is at the top of his field at that point in time. Again, all this looks fine on the first glance, but there are some nasty pitfalls here. If for some reason the amount to steal is passed as null, then the first conditional will result in a null pointer exception at runtime. Going further, if the dragon has no treasure at all, the get amount will throw another null pointer exception that may cause havoc in our application. And finally, for some reason, the person who was responsible for coding the morale engine, well, he might have assumed that if the morale level of our hero is at its lowest, we just set it to null. This will cause yet another null pointer exception to be thrown. We have to do something about it. Right. Now this feels safer already. We have covered the null check in the first two conditionals, and in the last one we have done a little trick. We have flipped the equals starting point from the hero to the actual enum entry. Enum entry can never be null, so we are guarded here, even if the morale is actually null. Technically, this will all work, but we are software artists. We want to make it even better. We have done a little bit of refactoring here. We have moved all those conditionals into private methods and named a larger conclusion in a more friendly way. Thanks to this, the next developer working on our code will have much easier time to understand it quickly.
In the first chapter, we have seen how to deal with magic numbers. Sometimes, though, a set of connected strings or numbers is really large. On top of that, each of the values may bring more than one trait with them. Going with constants stops making much sense at this point, and the need arises for a more slick solution. This is where enumerations shine and let us clean up our code considerably.
Going back to magic numbers, there is still room for improvement here. You can tell straight away that different moral levels influence the strength gained differently. With strength being the only addition, it is all still manageable. But imagine that the game director would also like to influence, at some point in the future, the dexterity, mana, and life of the hero. The amount of additional code would bloat the current class considerably and might break its single responsibility principle. Let us try to find another way. Okay, with enumerations coming into rescue, we might have saved the future headaches with this piece of functionality. We have created an enum entry for each of the morale levels. Then we have added an extra attribute for each of them, which is nothing else than our strength gain. Thanks to that, our original method have shrunk considerably. Also, if we would need to add dexterity management, then it is as simple as extending the enum and, what's most important, adding only one line to our main method.
We have gone through some of the most basic and core principles that should be applied not only to Java, but to any programming language you are working with. We know that leaving a bunch of numbers simply laying around without any context is not a good idea. We also know that it is better to put conclusions in your conditional instead of a string of small Boolean expressions. On top of that, if you brace your code, avoid null pointers, and think positively, the next developer working with your code will see a clean, slick piece of work. Okay guys, thanks for tuning in. I hope today's tips added a few ideas to your software craftsmanship toolkit. Also, if you found the content to be of value, then please subscribe to my channel. And remember, programming is supposed to be a creative, fun, and fulfilling experience. All you software artists out there, I'm looking forward to seeing you again on our next episode.